Hello everyone. I wanted to go over very quickly question number 6 from the 2012 AP free response questions because there were a fair number of people who missed parts of this question, particularly part D. So that's what I'll concentrate on, and I'll go more quickly through the other parts. So you're given the velocity equation, and you're also given that the position is -2 at time equals 0. So that means that S of 0 equals -2. In part A, they just want to know when the particle is moving to the left, and particle moving to the left would mean that velocity is less than 0. All you have to do is graph this velocity equation on your calculator and look for when the velocity is less than 0 on the time interval between 0 and 12. So I'm just going to do that in Desmos here. So I'm going to be looking from 0 to 12 here. And again, I was just looking for where it was negative. So it is negative from 3 until 9. And that's going to be my answer. In part B, it says write but do not evaluate an integral expression that gives a total distance traveled. So all you have to do, and they're going from 0 to 6, is remember that distance is the integral of the absolute value of velocity. And that's all you have to do for this question. They just want you to set it up. In part C, find the acceleration of the particle at time t. So the acceleration is going to be the derivative of velocity. A of t equals v prime of t. So to take the derivative of cosine, this is going to be my baby. The derivative of cosine is negative sine pi over 6t times the derivative of the baby, and that would just be times pi over 6. So I'm going to just rewrite that as negative pi over 6 sine pi over 6t. And then they want to know if the speed is increasing, decreasing, or neither. And remember that we know that speeding up is when the velocity and the acceleration have the same sign. And it is slowing down when the velocity and the acceleration have opposite signs. So that's kind of the definition that we're going for here. And they want us to tell them what's happening at time equals 4. So really just use your calculator to figure out A of 4. You can put this into your calculator as acceleration, and you're going to get a negative value, and then put into the velocity equation 4, and it's going to also pop out a negative value. So you know, since they have the same sign, it's speeding up. In other words, the speed is increasing at t equals 4 because acceleration and velocity have the same sign. That is a great answer, perfect justification. Now in part D, they actually want you to find the position of the particle at t equals 4. So remember that to get from velocity to position, you're going to take an antiderivative. Now, what do you know? They gave you one piece of information. So we know that S of 0 equals -2. And we're trying to find S of 4. And we know that position is going to be given by the antiderivative of the velocity function, right? But how are we going to figure this out? Well, we're going to use 0 and 4 as the bounds because we know something about 0 and we want to find out something about 4. So the integral from 0 to 4 of v of t dt equals the antiderivative of velocity, remember, is position, and we're evaluating that between 0 and 4. In other words, S of 4 minus S of 0. How do we solve for S of 4? S of 4 is simply our starting place, S of 0 in this case, plus the integral from 0 to 4 of v of t dt. I just want to take a quick moment to summarize something, okay? Let's say they tell us that S of 2 equals 10, and they want us to find S of 7, for example. What you would do there is you would use this as your starting point. So you would say S of 7 equals the starting point plus, you want to go to 7, but we're just going between 2 and 7 now. So you don't always have to work it out like I was doing all the steps. You just know wherever you're starting. So say you were doing S of 10 and you were starting at S of 3. Then you would add up starting at 3 and then the area from 3 to 10. So that's kind of how it works. This is always the proof of it. You don't have to write that out every time if you kind of get the hang of what's going on. If you'd rather just write it out, no harm. So let's go ahead and do what we know. So we know s of 0 is negative 2 plus the integral from 0 to 4 of cosine pi over 6t dt. Now, you can definitely just plug this into like Wolfram Alpha or something, but I'm going to do a u sub just for some practice here. Because obviously, if I was to take the derivative of this, I would need to chain it. So here I'm going to need a u sub. My u is going to be pi over 6t. So my du is just pi over 6 dt. I only have a dt here, so I'm going to just multiply by 6 over pi. Du is going to be my replacement for my dt. And I'm going to just do this out on the side so that I don't need to change the bounds. The integral of cosine u times 6 over pi du. I'm going to take the 6 over pi constant out. The antiderivative of cosine is just sine u plus c. So now I'm going to go back to here, and I have negative 2 plus, now I know the antiderivative is 6 over pi cosine, and the u, now I'm going back to t's, was pi over 6t, and then my bounds were 0 to 4. You see how I stuck with t's over here? That's why I can have my t bounds again. If I had a u here, then I would need u bounds. So you just have to be consistent. It doesn't matter what you choose, you just have to be consistent. If this is t's, these are t bounds. If this was u, these should be u bounds. So now I have negative 2 plus 6 over pi. The cosine of 4/6 pi is the same thing as 2/3 pi. And I'm really sorry, this should have been a sine, not a cosine. My answer was sine. So I'm doing sine of 2 pi over 3 minus now sine of 0, and the sine of 0 is just 0, minus 2 plus 6 over pi. The sine of 2 pi over 3 is root 3 over 2, and you can just leave your final answer like that. Minus 2 plus 6 over pi root 3 over 2. And that would be my final answer, and that's it for this video. Bye.